guys, welcome back to my YouTube channel. So our topic for today is introduction to distribution. But before anything else, let me identify whether the figure has a bell shape. Okay, so let's say this is a bell flower. Do you think that it has a bell shape? Yes, it's all because that this figure has a representation of the bell. How about this bell pepper? Do you think it has a bell shape? It seems not. Okay, it might have the name bell pepper, although when you come to see the shape, it doesn't seem that it represents a bell. How about this one? Yes, so this figure, it's a bell. So literally, it has a bell shape. Okay, so we're going to recall our previous lesson, which is the normal distribution. Okay, when we say a normal distribution, okay, the shape of it, it's a bell. Then when you're going to describe the curve, it is symmetric about its mean. So it means to say this mean is the axis of symmetry. Okay, keep in mind that the mean must be equal to its median and the mode. Then, the spread of the curve depends on the standard deviation of the distribution. Keep in mind that if the standard deviation is higher, then it will be more widespread. However, if the standard deviation is smaller, then it will be much more narrow. Okay, the tail of the curve flatten out indefinitely along the horizontal axis asymptotic to the axis. And keep in mind that the area under the curve is 1. If we split it into two halves through its definition, which is symmetric, okay, so each half is zero point 0.5 in terms of the area. Okay, so we're going to introduce a t-distribution. Okay, so when we say a t-distribution, it is used when a sample size is less than 30, and comparing to the normal distribution in terms of tails, it has heavier tails. So as we see that the tails are higher comparing to the standard normal distribution. However, in terms of the height, its peak is much lower. So we're going to relate in terms of geographical landforms. So the T distribution represents a hill, let's say Chocolate Hills. Then when we say a standard normal distribution, it represents a mountaintop. So it represents, okay, shall we say Mount Everest because of its high peak? Okay, so now we're going to analyze the graphs. Okay, when we say that the distribution, it is widely expected that it has a higher standard deviation because of its lower sample size. Why the Z distribution has a much more narrow figure? It's because the sample size is higher. Okay, we're going to use the concepts of practical research too. Okay, a researcher uses a non-probability sampling technique. Okay, I say convenience as the example. Okay, he has decided to choose 20 participants for his quantitative study. So if the number of participants is 20, then he will be using t-distribution. Okay, another researcher has decided to use a probability sampling technique. Okay, I'm going to give one example, which is simple random sampling technique. So when we say simple random sampling technique, okay, he will be forced to use many respondents as his subjects of the study. So okay, let's say he has chosen more than 30 respondents. So okay, the locale is the school. Then he has decided to choose simple random. Okay, he will be using the Sloven's formula to determine the sample size. Okay, so presumably the sample size is higher than 30, and since it's higher than 30, he's going to use the z distribution. Okay, then here let's compare this distribution. Okay, the peak of the curve is low. Why it is low? It's all because the standard deviation is higher than the z distribution. Okay, so why the peak of the curve is high? Because in z distribution, the standard deviation is much lower. So it means to say that the scores are much closer than in t distribution. Okay, the standard deviation is higher than 1. Okay, like what I had mentioned. And here in z distribution, the standard deviation is equal to 1. So based on these definitions, it is clearly implied that the t distribution has a higher standard deviation. Okay, one of the reasons why the standard deviation of t distribution is higher, it's because the sample size is lower. Okay, so the sample size is less than 30, while in z distribution, the sample size is higher than or equal to 30. Okay, so we're going to discuss more characteristics. Okay, so t distribution and z distribution are both bell-shaped curves. Then in t distribution and z distribution, they're also both symmetrical. Okay, then its entire area is one that applies to both of the distributions. Okay, so what are the degrees of freedom? Okay, so given its sample size, okay, what are we going to do is we're just going to subtract it with 1. Okay, so it is used, the n minus 1 concept is being used in finding the sample variance and the sample standard deviation. Okay, we're going to mention the meaning of degrees of freedom. It is known as a maximum number of independent values that are free to vary when estimating statistical parameters. Okay, so why do we need to use the degrees of freedom? So we can be able to find the t value, since in the t value table, there are degrees of freedom. The smaller the number of degrees of freedom, the curve will be flattened. It's because of the standard deviation, because it makes the standard deviation go high. So it needs to say that the scores have wide gap. Okay, which of the following sample sizes set can be used for t-table? Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 people in this picture. Okay, so practically speaking, that since 16 is less than 30, okay, so definitely yes, this can be used for t-table. Okay, for example, I'll be using these people as my respondents for my research study. But before anything else, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So clearly, there are 10 people here in this picture. So, and since this is less than 30, we can tell that this can be used for t-table. So, yes. Okay, so how about this one? It seems I'll be having a hard time counting because this picture is filled with people. So can I count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 9, 30. So clearly, so the number of people here is higher than 30. So do you think this can be used for the table? No. So this can be used for z distribution. Okay, so let me show you the t table. Okay, so let me discuss the parts. So here are the degrees of freedom. This is where you're going to see the degrees of freedom. This is located at the first column. Okay, so here for the significance level, here are the significance level. So the significant levels shown are 20%, 10%, 5%, 2%, 1%, and 0.1%. Okay, so here are the T values provided according to the degrees of freedom and the significant level. So this can be used for identifying the T value or using these concepts in testing the hypothesis involving T distribution. So this is a big help. So malaking tulong ito sa pag-estimate ng confidence interval involving sample sizes less than 30 and testing hypothesis involving this kind of concept. Okay, so now we're going to find the t value. So if the confidence level is 95 and the sample size is 16, so what is the t value? So first, so the given are the confidence level, which is 95%, and the sample size is 16. So what are we going to do first is we're going to subtract 16 with 1. So it will be 15. Okay, so we're going to find the degrees of freedom first. So we're going to subtract 16 with 1, which is 15. Then we're going to find the significance level. So in order to find the significance level, we're going to subtract 1 with the confidence level. So the confidence level is 0.95. So in terms of percentage, we're going to subtract 95 with 100%. So 100 minus 95% will be 5%. So the 5% is its significance level. So where are we going to locate the significance level, which is 5%? So here, which is 0.05. Okay, so now we're going to correspond the degrees of freedom, which is 15. So it points with 2.131. So are we sure that 2.131 is the t-value according to the degrees of freedom, which is 15? Okay, so we'll see. Correct. So this is the correct t-value because this corresponds to the significant level, which is 0.5, and the degrees of freedom, which is 15. Okay, so therefore, the correct answer is 2.131, which is the corresponding t-value according to the degrees of freedom, which is 15, and the significance level, which is 0.05. Okay, so now we're going to find the sample size. So the corresponding t-value is given along with the confidence level. So what is the sample size? So we're going to find the t-value, which is 2.977. But before that, we're going to find the significance level. So in order to find the significance level, we're going to subtract 100 with 99%, which is 1% or 0.01 in decimal form. Okay, so we're going to look for 2.977. Okay, so C, the 2.977 lies in the column of 0.01 as its significant level. Okay, so 2.977 corresponds to the degrees of freedom of 14. Okay. So since the t-value is 2.977 and the significance level is 1%, the corresponding degrees of freedom is 14. To get the sample size, we need to add the degrees of freedom, which is 14 with 1, which is 15. So the sample size is 15. Okay? So one last example. So finding the confidence level if the t-value is 2.086 and the sample size is 21, what is the confidence level? So our first step is we're going to find the degrees of freedom by subtracting 21 with 1, which is 20. So now we have 20 as the degrees of freedom. Then we're going to find the value, which is 2. 2.086. So this is the p-value pala. So we're going to locate 2.086 by using my arrows. So here, this corresponds to the degrees of freedom value, which is 20. Then we will see where it locates in terms of the significant level. So the 2.086 points up to 0.05. So that 0.05 is the significance level. Okay. In terms of percentage, it is 5%. Okay, to find the confidence level, okay, we're going to subtract it with 100. So 100 minus 5%, which is 95%. So now we're going to use the t-value calculator. Okay, so here, this allows us to input the degrees of freedom. So this calculator doesn't require us to use the t-table. So this is the shortcut. So in order for you to be able to find the t-value, so our degrees of freedom is 9, then our significance level is 0.05. So we're going to click the calculate. So this is the t-value according to the right tail or one tail. Then if it's two tail, it is plus or minus 2.26 and so on and so forth. So if you want to reset, click reset. Okay, we want to type another. So let's say this is 15, then this is 0.01. So automatically it will be shown. So this is the t-value according to the right tail. Then this is for the two tail. Okay, so this is the calculator that we can use to find the t-value. Okay, so now we're going to use the graphing calculator of t-distribution, which is Desmos. Okay, so as we see that we can control the number of sample size. Okay, so if it's higher than 30, as we see that the graph is being narrowed or that it is being higher. If we lower down the sample size, then the peak becomes lower. Okay, so it means to say that the standard deviation is higher and the curve has been widened. Okay, so this is where we're going to control the rejection region. Okay, so here the 0.37, this is the area of this curve. So this can determine us to find the area mismo. So dito, ito yung guide sa paghahanap ng area. Okay, so this allows us to shade the region. Okay, so if both regions are being shaded, then the two areas will be added. If it's shaded at one side only, then expect that the area will be small. So hindi lang siya pang t-distribution, but it can help us to know the area of the normal curve. Okay, so if it's between both values that have like signs, then expect that the area will be smaller than 50%. However, if both halves have shaded parts, or shall I say that the area we're in, the which is between both values that have opposite signs, then expect that the area is higher than 50%. Okay, so here is the degrees of freedom, the VDF, V sub DF, which is the degrees of freedom. Okay, so here's the formula of the degrees of freedom. Okay, so this is where we're going to control the sample size, and this is where we're going to control the Z or Z value, Z scores. This is where we're going to control the Z scores. So this can help us in knowing the area of the region, especially in PVC division. Okay, so do not forget to subscribe my YouTube channel and hit the notification bell. So have a great day, stay safe, happy learning, and God bless you. And I really hope that you will learn from watching this video. So keep watching and stay tuned for more videos. So have a great day.